Hey everyone, my name is Pradeep Banavara and I'm here to introduce you all to the topic of deep learning. Deep learning is integral to a self-driving car. My goal is to give you a holistic understanding of why this is, what's the importance of deep learning in a self-driving car, and also give you a basic understanding of how deep learning works. So let's dive right in. I've always found that learning a new concept is best done using a very practical and a simple use case. So let's do that. So let's say we have the image of a car and we want to somehow teach a computer to recognize this as that of a car. So what can we do? We have the image of a car. We can obviously uh, put a label to this car because we know it's a car. So now all we have to do is we have to somehow convert this image of a car to this label, which is a number, right? It's the label is nothing like it's just one for car, two for truck, three for bus, so on and so forth. We need to find a mechanism using which, given a car, we will get the output, which is a number. Now, let's say such a mechanism exists. And once we have that output, we can compare that output with what we know and then do something with this methodology so as to get the desired output. So let me simplify this a little bit. Let's assume we have a black box. The black box takes as input an image and outputs a number. Let's say it takes the image of a car and outputs the number 5. But we already have associated a number 1 with the car. So we know that this has to be number 1, whereas it is 5. So we know that, oh, 5 is greater than 1. So we need to change something in this black box and so that the output is closer to 1. Okay, let's say we do that in the first iteration. We change these parameters. We again run the image on this black box and see what the output is. Now let's say the output is 3. Now we know that, okay, we are at least on the right track. The output is reaching 1. Now you see where I'm going with this? Let's say in the next iteration, you reach the number 2 as output, which is a little bit closer to 1. So we know that, okay, we are again on the right track. We further fine tune the parameters and keep doing this until we are close to the number 1. At this point, let's say we reach this point, this black box is capable of taking an image and classifying it or recognizing it as a car. Let's say you feed it an image of a truck. It will not recognize it as that of a car, which means it will not give the output number 1. It might give a different output, we don't know, but it will definitely not give us 1. Now, how could such a simple concept be so powerful, right? You might be wondering how it is that this simple concept has become so popular, so powerful, doing such tasks like which were unthinkable a few years before. This is possible because the step that I mentioned, where you fine tune the parameters of the network, it happens automatically. It happens without human intervention. It happens by what is known popularly as backpropagation. Now, backpropagation is a loaded term, it's a fancy term. You will understand what is backpropagation later in the course, but for now, understand it as an algorithm or a function that can look at the output and change the parameters in the network so as the output reaches the desired output, right? Now, the difference between the output of this black box and the desired output is what is known as a loss function. The loss function is what enables this backpropagation algorithm to fine tune the parameters back. I mean, obviously, we write methods to fine tune this, but it is all done automatically. So, there is a black box that, given the input of an image of that of a car, it can classify this as that of a car, because it has gone through several iterations of this learning process, of this backpropagation process, where the parameters of this network have been tuned to recognize that of a car. This is all there is to it. This is at a very simplistic level what deep learning is all about. This black box is what we now refer to as an artificial neural network. It's it is supposed to be the closest representation of how a human brain functions in 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 software. The way human brain functions is that it is a set of neurons which are connected to each other by by axons, and the images are transmitted from the information is transmitted from one neuron to the other using some sort of a complicated non-linear methodology which known as activation. The same is emulated in a neural network. A neural network is a set of these neurons that are connected to each other by these activation functions, and information flows from one neuron to another, and the backpropagation algorithm fine tunes these neurons so that the desired output is reached. What are these neurons? They are nothing but simple matrices, but these matrices are often very large. Matrices of float parameters. That's a neural network, right? It's a stacked layer of matrices with a certain activation function, which is a nonlinear function. Again, in the next, in the coming days in the course, you'll understand what a nonlinear function is, why is it essential, and all that. But for now, it's a function that will enable these stacked layer of parameters to be learned efficiently using this backpropagation algorithm. Now, why does it have to be stacked? Why can't we put all these parameters in one large, huge matrix? That again you'll understand in the coming days in the course. So, why is it that deep learning, this methodology, if it works like this, I mean, this should have been popular way back when. I mean, the first perceptron was designed in the 70s. The first representation of a neuron in software was written in the 1970s, and the backpropagation algorithm was invented in the 1980s, in 86 to be very precise, by Geoffrey Hinton. So why did it take such a long time until 2010 or 2012 for deep learning to become so popular? The primary reason is that these matrices, the operations that you perform on these matrices, the fine tuning, is a very expensive operation to be done on conventional CPUs. Until the GPUs came into foray, which was in early 2010s, early 2008, 2009, this operation was not feasible. It was super expensive to run on a CPU. You would literally need a supercomputer to even recognize something as simple as a cat or a dog. The GPUs, the affordable GPUs, made it possible for such operations to be done super efficiently, and then deep learning just kicked off. So, what is possible and what is not possible? Right? Is it just for classifying or recognizing images of cars and trucks? No, absolutely not. The same concept, with some changes or a lot of changes in these parameters and the way these networks are designed, has enabled us to recognize not just images, but understand what part of an image is that of a cat. If there are multiple components in the image, understand each component, Come to think of it, how difficult it is to do all this in by crafting handwritten tools. It's almost impossible. It is possible now to classify each and every pixel in the image as belonging to a certain object that it represents. So let's say you had the image of a scene, and a machine can clearly identify the parts of a scene, that this is a mountain, this is a lake, this is a car, this is a river, so on and so forth. So it's it has made like the possibilities that were, like I said, like 15 years before, were thought to be impossible, or to be not accomplished by software. Deep learning has enabled us to do those things today. Now, coming back to self-driving cars, why do we need deep learning, right? So you might have now gotten an idea, and you might have guessed it, that it's mostly for recognizing images. But in self-driving cars, the primary function is to understand your surroundings. I mean, you should be able to look at the surroundings and understand if there is a pedestrian, if there is another car in front of you, um, if it is raining, if it is snowing, how different is the image, what should the car do, should it swerve, should it stop, if there is a pedestrian, at what speed is the car in front of me going, how do I alter my speed in relation to that of a car. So to do all this, the fundamental requirement is perception, right? The car should be able to perceive. So for this, the self-driving car is equipped with cameras, with not just one or two cameras, but multiple cameras, to see and understand, to look and examine the surroundings. The other common problem is a blind spot, right? If there is another car coming in the other lane, how do I see it before we make a lane change? Even we humans have to pay so much attention when we are changing lanes. So imagine the difficulty a car has uh, with these cameras that have limited abilities, right? And the car is traveling at a high speed. We are talking of 80, 90, or 100 miles per hour speeds, and the car being able to understand what the object is in its field of vision at that speed. It's super complicated, and deep learning makes it possible, right? At least it is. We have a line of sight. We are making enormous progress. uh, if you look at the technology, what was there 5 years back, and the technology that is there today in some of the most prominent self-driving cars, it's night and day difference. Yet we still have so much work to do. We are nowhere close to level 5 autonomy. We are nowhere close to understanding our surroundings in all weather conditions, rain, snow, fog, different levels of rain, and different lighting conditions, dawn, dusk, all those things. So it's a long road ahead, and deep learning gives us this. These deep neural networks give the fundamental tool set to build systems that are capable of achieving this human level perception that are much needed in self-driving cars to be fully autonomous and reach level 5 or level 6 autonomy. So I will leave you guys with that. I hope you get a basic idea of what a neural network is, what a deep neural network is, how it functions, what the parameters in the neural network are, what is this learning process, which is the backpropagation, and how do we fundamentally take this neural network, and then can we apply it to other domains,